Hi, my name is Emily Tang from Basis International School, Nanjing, and today I'm going to introduce my project, which is the discovery of Plumbagin as a novel and selective TRPV2 inhibitor to suppress neuroinflammation. First, let me introduce several backgrounds. The first one is neurodegenerative diseases. Neurodegenerative diseases are a group of disorders that damage brain cells. They include Alzheimer's disease, Parkinson's disease, and Huntington's disease, and etc. They affect millions of people all over the world. In the United States, they cause around 300,000 deaths and around 3 million people disabled annually. The common health burden of neurodegenerative diseases is around $655 billion in the United States in 2020. Unfortunately, more people are getting neurodegenerative diseases nowadays. However, there is no effective treatment in the clinical practice. The second one is microglia cells. Microglia are a type of brain cells. They make up about 10% of our brain cells. They are very important because they protect our central nervous system, and they also keep our brain healthy by cleaning up the damaged cells. They also act like the macrophages in the brain. However, if microglia stay active for too long, they actually start to release some harmful chemicals, and these chemicals will cause inflammation or the damage to the brain cells. And these two are the key factors that contributed to neurodegenerative diseases. The third one is TRPV2, which is a special kind of ion channel, which stand for transient receptor potential cation channel subfamily V member 2. And they form pores to allow ions like sodium and potassium to move in the cell and out of the cell by passing through the membrane. TRPV2 is very important because they help us to sense the heat. They also have the TRPV family, such as TRPV1, TRPV3, and TRPV4. They're also important in the immune system. However, the scientists do not find any activators or inhibitors that can fully activate or block the TRPV2 expression. Thus, it is very hard to understand and explain exactly how TRPV2 works. Due to the development of structural biology, TRPV2 cryo-electron microscopy has been resolved. Then I hypothesized that, first, structure-based virtual screen can facilitate the discovery of potential TRPV2 inhibitors. Second, TRPV2 channels are important regulators of microglia inflammation. Third, by using inhibitor to block TRPV2, it might be possible to reduce inflammation in the microglia cells. And this could be a new way to treat neurodegenerative diseases, which currently is an unsolved and severe problem. To fulfill our objectives, we started a virtual screen to discover potential compounds that interact TRPV2. We then, using FLIPR, the calcium imaging technique, to test the effects of this compound on the 2-APP-induced calcium influx in the TRPV2 HEC 2093 cells to discover TRPV2 inhibitors. Then, the best TRPV2 inhibitor was validated using PatchChem, which is the ion gold channel for the research. To test the selectivity, we examined the TRPV2 inhibitor on the homologous TRPV channels, including TRPV1, V3, and V4. We also explored the mechanism of inhibitor to suppress TRPV2 activity in the combination of mutagenesis via FLIPR. Finally, we're using qPCR to test the TRPV2 inhibitors on the mRNA expression level of the inflammatory mediators in the microglia BV2 cells. Finally, after doing researches, conducting experiments, and analyzing data, I concluded that, first, structure-based virtual screening discovered Plumbagin as a novel and selective TRPV2 inhibitor. Second, Plumbagin interacts extracellular pocket formed by the pore helix and transmembrane helix strand 6 of the TRPV2 to display inhibitor effect. The last one and the most important one is Plumbagin inhibits inflammatory response in microglia cells, providing a novel target and lead compound to manifest neuronal inflammation, providing the potential lead compound for neurodegenerative diseases. And that's all. Thank you. Bye.